Hey guys, Fardos and Babu, aka FSB here. So now let's talk about most asked JavaScript interview questions in this video. And yeah, I'm super excited to talk about the top five most frequent coding concepts for JavaScript interviews. So we will go over scope, closures, and the event loop, promises, and finally the module system. And the number one concept is scope. You really want to understand at any point in which scope it's something available. A senior developer immediately by looking at a code knows that this variable right here, it's in what we call the module scope. It is inside, it's available to this module, but it is not available to any other module. And they also know that, for example, this inner variable, it is not available in the scope of these other functions because they are in scope that are siblings. They are the same level. This inner variable, it's inside the scope, which makes it not available to this other one. Remember, bad developers care about code, good developers care about data, and data in JavaScript lives in scope. So the next concept is closures. Whenever we create a function in JavaScript, it will enclose the lexical context, which basically means all these scopes where it was created. That means this create counter function will always have access to the app name variable because app name, it's in the module scope where this function was created. But the same goes for very nested functions. If we look at the increment function, regardless of where you will use this function, you will always have access to this count variable because count it's in the local scope where function increment was created. Regardless of if you use the increment here or create increment in a totally different file, let's say you import this function, you will always be able to access this, and all these variables will keep be available in the memory for as long as someone still needs the increment function. The garbage collection algorithm will not free this allocated memory. The third concept is the event loop. And the event loop is the way JavaScript executes code. The easiest way to explain this is by trying to see how this piece of code will be executed. Basically, whenever we have synchronous code like function calls or instructions, they will get added to the stack. We will add basically the instructions here and then start executing them until we finish. So in the case of console log, the first thing we'll log in this case, the console would be this word start. Now moving on to timer function, these are a bit more complicated. The reason is because they actually enable us to run things asynchronously. So even if in this timer function, we say we will execute this in 0 seconds, it will not get pushed to the call stack directly. The callback, it will be pushed to the micro tasks and it will stay there until we finish everything in the stack, and anything that might be in the micro task, that is what's called an event loop tick. Basically, we execute everything in a stack, we have execute everything in the micro tasks, and we render the UI, so we repaint the interface and the users see we are actually responsive, and that's it, and we finish the tick, and then we move on to the next micro tasks. In the micro task here, you might have things like on click events or on keyboard events, pretty much anything that gets scheduled there. Moving on, we have another edge case in asynchronous programming with JavaScript, which is a case in which a promised object will resolve. And we have this callback, and this other callback to run again. Those things will not be added directly to the stack but be pushed to the micro tasks. So both promise 1 and 2 are pushed over here, and they'll stay there until we finish everything in the stack. So we will still have this other thing, which is console log, in which will now execute. So basically we had start executing in first place, we had end executing in second place, and now we start executing what's in the microtasks in microtasks. So basically we will execute promise 1, which is the first thing in our microtasks. Then that would be number 3. Then we execute the number 4, and now we finish the event and we repaint the browser, and finally we execute the callback of set timeout that was added to the microtasks. That would be number 5. And so the next concept is promises, and we have already seen beatable promises when we were talking about call stack. A promise, it's basically an object that will resolve in the future. It will return a value at some point in the future. When we create a promise, it will always be in the status of pending, and it can either be fulfilled or rejected. The reason why promises were invented was to handle asynchronous programming in JavaScript. Back in the days before promises, we could only have asynchronous tasks running with callbacks. Basically, if we wanted some code to run after something has finished, we would pass that code as a function. We would wait and do our synchronous operation. In this case, it's just a timeout, and finally invoke our callback. And the problem with this is that whenever you go to many levels, it can become extremely hard to debug, and you can have very hard errors, and it's extremely hard also to do error handling. If we look at a more heavy examples, imagine we have a file function that creates a file asynchronously, then it calls a callback, which in this case will be another function that validates the data, which can also call a callback. Then there is a transform data, same procedure, and send data, and this is kind of a mock file processor, let's say. To use all this with the callback notation, you would end up having this kind of function call. We will get file, then pass the next callback, then validate data would have its own callback, and this is what we call callback hell. As you can see, if we have any exception around here, it's extremely hard to debug. This is very nested, so talking about closures and in closing, in scope, it's extremely hard to understand what are the variables here and read this code. And this is what they call a callback hell. To solve this, we can use promises, and with promise notation, we can rewrite all these functions to return a promise. Promises are smarter objects, and we can use them like this. We can actually have one promise that it's from read file, and then on that promise call that value the data, which returns another promise, so we can use that then again, and then transform data, and then send data to server, and then log completion, and we can use dot catch to handle errors. So this is a lot easier to understand, and it is a lot easier to read. But guess what, JavaScript also introduced, based on promises, a sync await, which is just a syntax sugar. It's a better way to write synchronous code like this one that looks asynchronous. And if we go back and rewrite this, it will look like this, where the file data would do something, then we validate and we transform, and then we do the result. And this looks like synchronous code, one after the other, but in reality, it leverages the event loop and run as synchronously. What do you want to take out of this? I wouldn't even think about interviewing if I wouldn't understand what callback notation is and what promises are and what callback hell is and how to use the promise constructor in this case to make a function return a promise. And if you go and interview in today's market without knowing those things, you will be wasting your time. Make sure you understand them and make sure you are able to translate from these both formats and understanding scopes, closures, promises, and the event loop. It's not enough. We also need to know very well the module system. Basically, JavaScript used to be a language where we had no modules. We just added a script to a web page, but sooner developers understood that we do need modules. We do need a way to isolate code and be able to reuse code. And the first way to do that was by using immediately invoked function. Remember our conversation on scope. Basically, inside of this function, we have a function scope. Every variable inside here, it's only available in this scope. And so a way for us to isolate things is just to create a function that is invoked immediately, which means everything inside here will not be accessible to the outer world because pretty much no one can actually run that function again. It's not even named, it will just run. We have a way of kind of private namespace, which is what modules gives us. Isolation, and we can have another module. It's using exact same variable name, but remember these two scopes are at the same level. They are totally different, and that's why this variable has nothing to do with the other ones. So this would work, and this used to be the way jQuery was written. However, it was extremely robust, and evolution of this was common.js modules, which I have over here, where you can actually declare variables, and then we have function in a file, and then we can add them to the module export. This is what's available from this function, and whoever wants to use this can use the require function to get it. The problem here is that it's still far away from modern module system, and there is so many limitations. For example, we cannot really do static analysis of our code. Static analysis, it's a way for us to somehow, before executing this module, know certain things about it. So we can do, for example, things like removing that code, aka tree shaking. You cannot do that with require because this code, this require is a function. It would only execute when you run the code. And this is one of the problems with the old CommonJS modules. Node.js, it's still running mostly on CommonJS. And now the latest evolution of this was the ES6 modules, which is what you've probably been using if you write code today, where we annotate, we declare what a module export, and then can use the import keyword to import different things. And the cool thing about this one is that module bundlers like Webpack or Vite can actually look at these imports and exports and see if there's anything in our code we are not actually using, what we call dead code. And they can actually drop that, and they can remove that at build time and have a much smaller bundler and much more performant application. And there are many benefits of static analysis in import and export. Allows us to have this more modern module system with static analysis, where we can actually understand how our modules are being structured, and on the structure, which is what we call a dependency graph with certain transformations. Knowing how the module system works will solidify your knowledge not only of writing JavaScript code, but how you can actually package and ship that to production.